Bismillahirrahmanirrahim. Assalamualaikum and good morning to Professor, Dr. Sir and Madam. My name is Muhammad Nazwan Mewagimin. I shall present my research proposal, which is a hybrid convolutional neural network model for predicting mango chlorophyll content. My supervisor is Associate Professor Technology Dr. Syukur Sanim Muhammad Fauzi and Associate Professor Dr. Chua Tet Seng. Okay. Currently, we facing a global food crisis. In the global food crisis, they come up with the ideas of precision agriculture, which is consists of the information technology and sensor and robotic technologies. In the precision agriculture, prediction model is one of the element in the precision agriculture. What we can do or we can use for the prediction model, we can predict a chlorophyll content of the plant. Why? Why chlorophyll content? Because chlorophyll content can shows us the condition of the plant. Because chlorophyll shows the development of the plant. That's why we can see from the chlorophyll content. Either the plant is healthy or stressed. So to identify the chlorophyll content, usually there is two or traditional method, which are the laboratory methods and the single device method. These two methods is better in the small area of farm, but for the largest area of farm, is quite unsuitable because it's time consuming and expensive cost. Therefore, my study is focusing to develop a prediction model to help the farmers in the large area of farm. For example, the FGV, they plan to open the bigger scale farm, maize farm in the Perlis. So we hope that we can contribute on that particular company, corporate sector. So the motivation of this study is there is two motivation of this study. For the first one, we want to provide an accurate alternative method to replace the traditional method for the large area of farm. The second motivation is because of the new technology. For example, previously when we do extract features, we must do a manual extract features. So high possibilities of human error. So with the new technology such as convolutional neural network, it can automatically extract the features and reduce the human error. That's good things. And the second one is the multispectral sensor withdrawn. Because previously we take the data of multispectral, we using a satellite. Satellite is far away from the Earth. That's why when there is a cloud there, so we don't get the good image. So by using a drone and multispectral sensor, we can use it rapid and we can control the height of the flight. So we can get the high resolution multispectral image for the large area of farm. So the significance of this study, why we want to do this study? Because we want to provide a good alternative method that can replace the traditional method, which are time consuming and expensive costs, in predicting the chlorophyll content. So when we talk about chlorophyll content, the farmers can improve their management, the farm management, regarding the nitrogen fertilizer. So we just only focusing on the nitrogen fertilizer. For the future study, actually they can study on the chlorophyll content, but extend to the other plant stress. For example, a disease attack, water problem, or chemical issue. Okay, that's why we want to do this study. Okay, the issue is this is how we run the study, my study, uh, which is the issue is how the difficulties of identify the chlorophyll content using the precision agriculture for covering the large farm area. So from this issue, we derive three problem statement, which is low spatial resolution will reduce the accuracy of features extraction in the prediction model. The second problem statement is unsuitable classification algorithm will reduce the accuracy of the prediction model. And the last one is a lot of the study on the chlorophyll content, they didn't emphasize on the generalization evaluation. With the study of the if the prediction model generalized enough, it can be used in the complex environment such as a real farm. Okay, so from this problem statement, we come up with this 3 research objectives. The research objective first, number 1 is we want to produce a high resolution, or we want to create a high resolution multispectral image with the canopy scale level of plant to solve the problem of the low spatial resolution. The second objective is we want to develop a chlorophyll content prediction model by using the suitable classification algorithm. And the third one, we want to evaluate the generalization of the developed prediction model using the cross-validation to make sure that it can be used in the real world. From the research objective, the 3 research objectives, we come up with the 5 research questions. When we answer this research question, means that the objective already achieved. We can achieve the objective by answering the research question. The first research question, how to collect the high resolution multispectral image? The second question is how to collect and group the chlorophyll content index based on the nitrogen level, because our scope is on the nitrogen level. And the third research question is which classification algorithm are suitable for developing a chlorophyll content prediction model. The fourth research question is what the measurement that we can use for measurement metrics we can use for to evaluate the performance of the prediction model. And the last one is what type of cross validation that we can use to evaluate the prediction model. Okay, so our scope is focusing on the harum manis mango venue at the UiTM Perlis, with the number of sample is 303. The data that we will take is only 2, which is multispectral image and SPAD reading. The spectrum for the multispectral that we focus on is only red, green, and near-infrared, with the 11 years old mango tree, and the time of sampling we take is around 8:30 a.m. until 11:30 a.m. and duration is for every 2 weeks. So this is the literature review structure. So the first one is the overview of the chlorophyll content is a continuity of the background story of the chapter 1. And we talk about the related works and the framework, which consists of theoretical and conceptual framework to develop a hypothesis. And the rest is to answer all the research questions. This is how we want to group, because this is come out from the Bailey and Steele 2013 and Knight and Buck 2017. Both of the paper study about the chlorophyll content index and mango leaf nitrogen. So we can group all the image and the group of the chlorophyll based on their paper. This is taken from the related works. Okay, this is the most important. What's the gaps on my study? Okay, the first one, actually, my study is contributing on the methodological area for the knowledge gap. So a lot of previous study, they teach the prediction model using a spectrogram graph image and leaf scale level image. But my study will extend to the monoband spectral images, which is covering on the red, green, and near infrared spectrum band. And we will use a canopy scale level of image. So this is the extendable of the extent or as extension of the gap in my study. The second one is other study, they use a CNN to predict for the CNN prediction. And there is a one study that use, not one, there is a lot of study that use CNN and LSTM for nutrient deficiency. So we want to try the CNN LSTM in the prediction, the chlorophyll content prediction model. So that is the extension of our study. And the third one is a lot of study just focusing on the accuracy, precision, recall, and F1 score performance evaluation. But in our study, we try to extend it to the cross validation to prove that the LSTM able to increase the model performance. Okay. This study using three theory, which is the first theory, we know that chlorophyll content can be reflected by seeing the visible and near infrared spectral band. So is this the dataset features? The second one, or the second theory is we know that CNN it can automatically extract the features of the image. So to reduce the human error. Okay. So that's called a features extraction. And the last one that we know that the hybrid algorithm can improve the accuracy of performance of the model. So we thought about is that is the type of the algorithm. So this is the three theory. Then this three is called as an independent variable. We classify it as an independent variable. So in the conceptual framework, there is three independent variable which are dataset features, features extraction, and type of algorithm. So what our study want to do? What my study want to do? We want to study this conceptual framework of this study is to evaluate the classification algorithm, which classification algorithm has the highest performance accuracy when trained the model using the mono band spectral image dataset. This is the one that we will generate the dataset, the high resolution dataset. So we want to study what? We want to study the high performance of algorithm. High performance, which one is having a high performance algorithm? How to say? Um, we want to study which one the algorithm that has a high performance accuracy when we train the prediction model using the mono band spectral image. Yeah. So we want to verify the hypothesis a suitable classification algorithm can improve the accuracy performance of the hybrid chlorophyll content prediction model. So this is the framework research framework. The first one, we will take data sampling. The data sampling consists of the multispectral image. We use this flight plan to get the lowest GSD, the ground sampling distance, which is the more detail on the picture. And the second data set is we will take the data of the SPAD for 32 leaf per tree. Then when we already collect all the data with the images, we will plot the histogram to make sure that the group is have a balanced data number. So we can use the data of the image. If we get the plot histogram, is objective number one is achieved or completed. So we can use the data to build the prediction model using the CNN and SVM, and also CNN and LSTM. So when we already built the prediction model, then research objective number 2 is completed. Then we will do the cross validation using the tenfold cross validation to evaluate the generalization. So from this one, we can know that it's the research objective number 3 is completed. So this is for the model framework, is more detailed. What we do in the model part, what we do is we will take the data sample, then we make sure that every group, just now we talk about low, optimum, and high group. Then we make sure that all group have a 50, at least 50 sample each group. Then we will divide the data to 70-30%, means 70% for training and 30% for testing. In the algorithm part, we using a Python, Google Colab, and TensorFlow to create the algorithm and the prediction model. We know that the CNN have a two part, which is a convolutional layer that extract the features of the images. And the second part is fully connected layer. The one that we will change when we talk about hybrid, the one that we will change, the part that we will change is on the fully connected layer. We can change to the support vector machine or long short term memory. So the convolutional layer still be using the same one, but the classification algorithm that we change, either using the fully CNN, or we want to attach with the SVM and also attach with the LSTM. So this is the part that we do for the algorithm, then the model creation, and we do the prediction result, and we evaluate the model and accuracy, precision recall, and F1 score. So after this done, then we can use the tenfold cross validation to make sure the generalization of the model. So this is the one that we will do for the research framework. Okay, so we expect the research outcome is plot histogram, total number of image for the objective number 1. The objective number 2, we expect that there is a CNN, SVM, and LSTM, the prediction model, and the measurement of the metric result. Then we can see that when we have the metric result, the normal measurement metric result, then we know that the model is done enough, is completed. And the last one, for the third objective, we will see the result of the tenfold cross validation. Okay. So the research approach, the first one, we will data collection, data pre-processing, that labeling all the images, and we will do the plot histogram of the CC index group. And the research objective number 2, we will select the machine learning and deep learning algorithm. We will develop the model, and we will train the model using the 70% and 30% of data, and evaluate the metrics. We will come up with the evaluation metrics of the chlorophyll content prediction model. And the last one, for the research objective number 3, we will test on the tenfold cross validation to get the result. So we know that either which prediction model have the highest accuracy in the generalization evaluation. This is the study plan. So the study plan will focusing on the data collection, data processing, data presentation using histogram, model development, model evaluation, and model validation. And then the last or not least is about the thesis writing and the thesis submission. Okay, that's all from me. So this is all the study. This is the research. This is the plan of my proposal research. So hopefully by this study, we will be able to contribute to the society government, and social uh, to improve the agriculture production to help in the to help to overcome the food crisis issue. All right. Thank you very much. That's all from me. So if there is any question and answer, thank you.